All right, guys, welcome to class today. We're going to take a look at an interesting solution that can happen or interesting situation that can happen when you're solving um, double-sided equations. So we're looking at a standard double-sided equation. We've got n's on both sides. So hopefully out there you're looking at this and like, oh, I want to get n's to one side, so I'm going to try to subtract 8n from both sides of the equation. So you can go ahead and do that. You subtract 8n's from both sides of the equation. All right, so let's take a look at what's going to happen on the left-hand side. And you're probably already looking at this and seeing what is about to happen. Let's go with purple here. I'm going to subtract 8n from that side, and I have nothing left on that side but 5. So looking at the right side, I take 8n, I subtract 8n, and those also are going to cancel out to 0. And I'm left with this solution that says 5 is equal to negative 12. And then you have to ask yourself, does 5 equal negative 12? And of course it does not. This is not true. This is false. This is a false statement, right? This is not true. 5 does not equal negative 12. Therefore, this unique situation occurs. If this happens, and it can happen, that we end up with a false statement and we're at a roadblock, there is no solution to your problem. This is the first time that we've seen this year, but it can happen, right? You get to this roadblock and there's a false statement. There is no solution for the equation, meaning that there is no number that you could put in for the variable n to make the statement true. There is no solution. There is no real number for n that can make these statements true. So how do you represent that in math language? You look at this. You say n is equal to the null set. So that would be the solution to your problem. You would say n equals the null set. And it looks like a little 0 with a line drawn through it. By hand, I would go like that, right? All right, so that's one situation that can happen. But there's a different situation altogether that can happen. And it looks similar, but it's actually the complete opposite thing. So we have another double-sided equation. Negative 6n plus 17 is equal to 17 subtract 6 times the number n. So I need to move n's to one side, from one side to the other side, first and foremost. So I'm going to go ahead and do that. So it subtracts here, and I'm left with 17. And on the other side, negative 6n plus 6n also cancels out, and I'm left with a statement that says 17 is equal to 17. And in this case, this is a true statement. This is absolutely true. Okay? So in this case, any value of n is going to work. Any value of n. So I could put in my favorite number, which would be 12, and that would work. I could put in your favorite number, whatever that might be, and that would work. That could be an n. I could put in pi or phi or any irrational number, anything that is infinitely large or infinitely small, negative, positive number. Any real number will be a sufficient solution to the equation. Now, that doesn't really help us that much because we still don't know what n's value is precisely, right? So it's just as useless as the last scenario where we have found there's nothing that n could be. But this one, it could be anything, any real number. And you would say that n is equal to all real numbers. The solution for n is equal to all reals. All right, so just draw a little reinforced R there, and you're good to go. So there's two situations that can occur, one of which, if there's a false statement, it's the null set. N is equal to the null set, no real solution. But the opposite is, if you end up with a true statement and you're at a roadblock and you can't solve any further, n is equal to any real number. That does it for today. That's pretty much the only thing that you're going to run into that's different on practice session 6.32. If you end up in any of these roadblocks, you got to know the difference between a all real solution and a null set. See you next time.